Hi, in this video, we're going to be looking at more examples of solving word problems involving Newton's second law. So in this case, we have an irresponsible student named Jay who was texting and driving and didn't notice a squirrel in the street at first. His 570 kilogram car was moving at 21.0 meters per second when it began skidding to a stop, encountering a frictional force of 18,000 newtons. What is the acceleration of the car? All right, so we are analyzing the car's motion here. And so we're going to analyze the forces on the car. I've already drawn my picture. The car is moving to the right for the velocity. So for the forces, we're going to identify first gravity. The car has a force of gravity pulling it towards the earth. The road supplies a balancing support force. We call that the normal force, pushing up against the car. And if the car is moving to the right and it's slowing down, then we have a frictional force acting to the left. And that's because it's slowing down and it's moving to the right. We don't have any air resistance in this example. I should have said neglect air resistance. In this case, we just have the frictional force. So the horizontal net force is just going to be one force here. There's no rightward force. The car is not being pushed forward anymore by the gas. So the horizontal net force is just the frictional force. The vertical net force, normal plus gravity, is just 0. So we're looking for the acceleration of the car. That's what we really want to know. That's our unknown. So I'm going to skip a step. I'm just going to write down what is the acceleration of the car. Let's write down also we have the kilograms. So that means we're given the mass of the car, which is 570 kilograms. We're also given that the car was moving at a speed of 21 meters per second before it started slowing down. So the initial speed was 21.0 meters per second. The final speed of the car is 0 because it said it skidded to a stop. And it says it has a frictional force of 18,000 newtons. So I'm going to write that over here. Now, because force is a vector, we should include the direction. So is this going to be positive or negative? If it's to the left, it's negative. So we need to make sure to include that negative sign there. It's a pretty important step. So we're looking for the acceleration of the car. If we look at Newton's second law, the acceleration is given by net force divided by the mass. So we have the mass of the car. Do we have the net force? If you recall, the net force right here is, in this case, equal to the frictional force. So we actually already have the net force. It is 18,000 newtons in the negative direction. That is the net force in this case. So we can simply just use this equation. We'll write acceleration equals the net force over the mass. And I'm just going to rewrite this one more time just to be clear. The net force in this example is the frictional force only. There could be other examples where you have like an applied force as well. So you would add that up here and add the two forces together. But we don't have an applied force in this case, so we don't have to worry about that. So we're ready to substitute in some numbers. The net force is negative 18,000 newtons. The mass is 570 kilograms. So put that into our calculator. 18,000 divided by 570. That gives us, rounded to two significant figures, negative 32 meters per second squared. So the acceleration of the car is negative 32 meters per second squared. So shorter example, but just some other examples you might see as you're trying to think through how to use Newton's second law. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.